post in your e-learning platform. Please ensure that your e-learning platform is function. And in fact, the submission of the papers are all in e-learning. Please be ensure that your e-learning is in good condition or running. Okay, so I have no idea when will be the platform e-learning typically for the test will be ready for you to you know um, to look around, for example. But inshallah, a week before or 2 days or 3 days before the exam or for the test date, the platform will be ready. Okay, so that is one. The other one is the test topic will be also discussed a week before the test because we haven't meet. I mean, all the lecture have been meet regarding the test. So the test topic will be inshallah. And I will also do the revision, and that revision class is open to everyone. So you can call up your friend to join the class. Typically, the revision class will be at night time. The revision class is basically solving all problems typically on the previous or past test or previous exam question related with the topics. Okay, that's about it for the information. Pass around the information to your friend. Those who are not, turn up today. Okay, the other thing is the assignment. I received assignment, assignment 1, 2, and 3. The fourth assignment coming, inshallah, when we completed this gyroscopic effect of gyroscopic, that will becoming your fourth assignment. Again, all assignment as mentioned, done in book and all in groups. So please be ensure that you collect your from your friend, you compile and you send to me. Don't send individually because a couple of groups send individually. Very difficult for me to trace from which group to which group. Yeah, so please ensure that you compile your work and one or your head of your group will send emails. Okay, that's about it regarding this information, the latest information. And I will change the what do you call it, this uh, sh- sharing slide. Yeah, I'm going to share with you the PDF, which I believe is easier for me to do something or work on it. Yeah, so last meeting was this one. Yeah, last meeting was talking about the example that you have. The first example on page 165. You can go back, and I think you already done this one. I think you also done the revision on your own, isn't it, about the first example. So it is not very difficult. This is the exact second example. This one, second example, also in your books on page 166. So I'm going to explain this one a bit and not doing that one complete because it's not point. Yeah, I keep repeating what you have in your head. So I'm going to share with you how to solve the problem. Typically on gyroscopic rotor and shaft. Late of this lecture or session, we're going to look for another subtopic, or sorry, another special application on aircraft, aeroplane, aircraft, or perhaps what do you call it, helicopter, and then we're going to look for the naval ship or boat, speedboat. Then, inshallah, next coming week, we're going to look for vehicles, trolleys, and so forth. Okay. So allow me to share this one example on page 166. And what you have here, if you can read, if you can, go through your notes, you have, if I can put a big mark here. Okay, right. Yeah. So what you have is figure show a shaft and this. So this one is shaft, this one is this. Or sometimes we call rotor, doesn't matter. Yeah. So shaft and this are supported by bearing NAB. This one bearing A and bearing B. Okay, shaft ABC negligible mass. This one negligible mass. The reason the equation tell you that this ABC is negligible mass because otherwise you have to look for the mass moment inertia. We have to look the mass moment inertia for the entire structure. This one. Even though you've done this one in dynamics, then you have to look for centroids. If they do not provide centroid, you have to look for centroid by using the application or the equation from statics. Otherwise, you have to cut into two pieces. One will be the disc and the other one will be the shaft. So most likely, uh, to ease the example, so the shaft here is negligible mass. Remember that one, yeah. If they provide you mass here, you have to look for the mass moment initial of the shaft itself. Then what that is saying is say that and even though it negligible mass, it will be rotating at it rotate at 15 radian per second with the disc of mass 5 kg. This one is 5 kg, spinning about 200 radian per second. And I did mention about in my class, the previous class, that the spin velocity is higher compared to the precession velocity. In the given direction, this one is the given directions. Again, if the direction is not provided, you have to make your own judgment of where you're going to view the direction. So given length, blah 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 blah, and radius given 10 cm, determine magnitude and direction of resulting gyroscopic couple. Resulting mean that the effect, or perhaps we put it here, prime. Okay. The other one is the reaction on bearing. Reaction mean what? It's the component bearings. It is not the resultant. But if you look, if the question keep asking for resultant, then you have to look for the resultant. Otherwise, a reaction mean that the component of forces on bearing A and bearing B. Okay, so I'm going to move in solution. You have the solution with you here. This one. Turn to page 166. Last, you get my new slide, my new display. Yes or no?
Yes, Professor.
Okay, thank you for your response. Okay, now, first, as I mentioned earlier, yeah, what you need now is what the procedure. Otherwise, you do not know where to start, isn't it? So the procedure tells us that first you generate this equation. This is the equation. Then you look what part by part or one term after another. For example, look for I. This is I. And remember, I can use equation as mk square, or you can also in term of half mr squared, depending on the parameter given or provided. For example, here to provide you this radius, so you use this one. This one cannot be used. So you have to read the equation very, very careful. Yeah? So this will be the results. The next thing is the omega. And I did mention that omega, and even though, for example, yeah, this one is not provided, not provided, for example. So you know that the omega or the spin velocity is always greater than the precession velocity. So you have the 15 for the precession, the other one be 200 will be the spin velocity. Then you put in the equation, you will have this one. These are the gyroscopic couples. Okay, so you have this one. If the equation asking about the resulting, so you put this one, m equal to m prime is equal to 75 Newton meter. Because we are dealing with magnitudes, the equation doesn't tell us what be the direction. So that will be the result for the first part of the equation. Okay, and number one, you have the equation m equal to I dot omega cross precession. Number two, remember, you are constructing the gyroscopic vector diagram. So constructing gyroscopic vector diagram, and here you are going to use equation from the right hand Fleming rule and also thumb rule. Okay, and also thumb rule. Construct vector diagram following right hand Fleming rule as in figure this one. Okay, how is it? It's not very difficult. I'm going to use this figure. Yeah. So look at the equation. What the equation provides us. Can you follow me, class? Hello?
Doctor.
Okay, thank you. Thank you, Fatin. So this one is the what? The direction. So if you're moving from one end, for example, it seems that it be rotating counterclockwise, correct? So if you put if you put your thumb, look at it. If I can open, I can on my video here. I on my video. You look at you can on my video. This is thumb. Okay, thumb. So you're rotating counterclockwise. You're viewing for that one, and so be pointing that way. So be pointing this one. This omega will be pointing here. Okay. Then if you look for one end, for example, here, and this one is seen rotating what? Another counterclockwise. Correct. So you put your thumb rule and you hold the shaft. Imagine that you hold the shaft. As you're holding the shaft, it will be pointing to you. So it'll be pointing to you here with precision. The next one is to define where be the couple. So if you can construct the polygon, sorry, if you construct the vector, first you have this one. This one is the 3D vector diagram. Yeah. This one is the precision. Yeah. The next one is you put your right hand framing rule. Your spin here, then your thumb is here. Thumb will be your precision. The next one be your right the middle finger, which give you M active. And this is not our concern because they're talking about bearing, reaction on force on bearing. So our concern is to look the effects. So this one is the effects. This one on body, spinning body. This one is on bearing. So whatever you done now is this one looking for this effect. What is the effect? Is the application of by complying the third Newton law stated by action equal to reaction. Okay, so you take this one and put it in your graph here. Oh, sorry, not this one. Sorry, this one. The first one, the E one. This E, figure E. Upward, rotating that way. How is it? Pointing that way, rotating that way. If you look at from one point, from top, you found that it will be rotating counterclockwise. From bottom, it will be rotating clockwise. So it depends. So as long as you have this one, to comply this one, you have one force here, the other force here. If you read book, for example, they provide you SFG. G meaning that for the gyroscopics. This one I put it F prime, it is the same. Okay, it is the same. So FG is the gyroscopic. So you have this one. So as I mentioned here, you need to know what be the force. So applying the force or calculating the force, you have to use this one. Here. You have MFD. D will be 0.3 meter as provided. Then you have the F. So F will be 250. And again, as I mentioned earlier, you also need to name the force because you are engineer. You need to know why you need to name the force. Because when you are designing something, you call up the vendor. The vendor come to you, and the vendor would like to know what type of force. So you need to know what type of force. So perhaps when they say, okay, is it a shear force, of compression force, or tension force? We are saying this is a shear force because different bearing will have to withstand some different phenomena of the forces. So here it seems that it is what it is, the shear force. Look at here. This is a shear force. Where are you, shear force? Static dynamic. This one is a shear force or the dynamic shear force. How do you know? Because if the shear force means that it will be what? It will be rotating at the surface of the platform, surface, on surface, that shear force. It will tend to bend, it become tension or compression. So that is one part. Okay. Then you start doing for the for analysis. You are doing the reaction or statics. Remember, for reaction on bearing, you do static and also dynamic. This one is a dynamic. Static as usual. Static is as usual. Constructing the free body diagram and also applying the two equations coming from the moment and also forces. So this one, okay, this is the RB, this is the MG. This one because why? Because you have a this here. If you have a MG here, so you have another M. So this one only M1M. So this one is RA. This one is RB. I'm assuming that this RA pointing upward and pointing upward. So solving by these two equations, you found that what you have is RB and also RA. Yeah, this one RB pointing upwards. It is on shaft. What you need is on bearing pointing downward. The RV is pointing downward because you'll be getting negative here. So you invert the direction pointing upward. Okay, then you put together on this system, this one, and a part of that is this one. Put on the system here A pointing upward, this one B pointing. So this is the reaction component forces on bearing due to static and also dynamic. Supposingly, the question keep asking about the resultant, but very rare in the practicals you found that there is a resultant, because in designing the bearing, you need to know only the principal force. What is the principal force? The principal force will be due to tension, due to compression, and due to shear. There's no resultant. So remember that on designing the bearing, there's no resultant force. They are talking about the principal force. So in here, in mathematics, for example, if this question keep asking you about the resultant, so you look for the resultant. So the resultant, for example, for bearing B, for example, yeah, it is not very difficult. So it will be here, isn't it? So that will be the resultant. So you will have a summation of F resultant is equal to 250 power of 2 plus 49.05 power of 2 square root. You get another result for B. Do the same thing for A. So that will be the resultant. And of course, because we are talking about vector, you also need to know what be the direction. Okay. So that's about it. So that is the completion of the examples.
Doctor,
Yes.
for the reactive moment, when we want to find the force, the reactive force, the F, so we assume that the moment M reactive is at the middle of A or B,
Yes.
or instead of assume that it at point C, right?
It look at here. It is not basically at the middle, yeah. Sorry. If you found that you have a rotor and the rotor is symmetry, you know symmetry, it will be the midspan, so it will be in the middle. But if it is not symmetry, for example, it will be fall on your your center of gravity, isn't it? Isn't
Okay,
it? Because here this is due to the equilibrium. But very fortunate that we found that this one, yeah, is, let's say this one is basically you have 0.3, another 0.3. So basically this one, the whole rod is 0.6. So it will fall at the middles.
Understand, doctor.
Okay. So if you found that the rotor, for example, is not uniform, it will not fall in the middle. It will depending on the centroid. So the CG, the mass, the couple will be fall at this CG. Okay, I'm answering your question.
Yes, yes, doctor.
Okay, any other question before we move on to the next one? Okay, now if there's no question, I would like to share with you about this one. Yeah, this one. This one, you have an example. This one on page 160. I'm not going to solve this one. I'm going to take the what you call it. Yeah, I'm going to take only the different. It's not different case. Special case on calculating the force on bolt and nut. You have the slide here. You have the slide will be on special case. This one. Special case. You have the slide here. Turn to your slide. So this one is typically due to when you have a motor, the motor is tightened up by a certain numbers of bolt and nut. So many rows. For example, you're talking about when the aeroplane engine, yeah, the turbine is holding by at the flapper or wings by so many or hundred of rivet. So we are going to look for the one, yeah, later on, inshallah. So supposingly you have this one, you have only here, yeah, you have this one, 1 meter. This one you have 1 meter, another 1 meter, which you have three rows, sorry, 1 row, 2 rows, 3 rows. This only 2 rows. Okay, so now the answer is this one. Supposingly, listen up very careful, class. If you read my notes, it is not confusing, yeah. It's very difficult to memorize, to remember, or to understand. This one is easy. I'm going to give you the easiest way to define what will be the maximum force on each bolt and nut. If you have so many numbers of bolt and nut, if you have only 2 rows, it's not easy. You have many rows, very difficult for you, yeah. So let's see this one. Let's assume that you have this one. This one is M reactive. Can you observe I'm writing something on the screen on your slide? Yes or no?
Yes, doctor.
Okay. We have M reaction. So this one the direction, isn't it? So this one will be the force, correct? This one will be the force. To comply this one will be the force. This one will be the force. This one will be the force, correct? But not to forget, yeah, because along the line of AB, you still have another ball and nut, isn't it? This one you still have ball and nut. This one supposed to be.
Doctor, sorry, what? F reaction.
Sorry. Yes. What is your question then? Okay, if you don't repeat, I'm just continue the lecture, yeah. So you found that AB along the line AB have another row here. So this one be, if you considering this one C for example, yeah, you have another one. So now your calculation will be, I think I have a slide on the working example. Let me check whether I have with me or notes, yeah, about the one, yeah. Otherwise I will bearing 1 minute. If I have the one, so easier for me to explain. Okay, doesn't matter. I'm going to explain this one. Then I go back to this, figure. Yeah, doesn't matter. Then I go back to the figure. This one, yeah. Okay, this one. So supposingly, as I mentioned earlier, if you go back to this one, yeah. So I'm going to have as such. Yep. This is very important class as such. This is bolt and nut. Two pieces, for example, yeah, bolt and nut. And you did found that the M prime, reactive will be pointing, the other way around. So this one, the M prime. So your direction, this one is M prime. This is your direction counterclockwise, pointing away. Sorry, the other way around. It should be the other way around. The other way around. Yeah. Sorry, this one. Yeah, this one. Then it's correct, isn't it? So we have one force. This one's correct, or not? Yeah, it is correct. Yeah. This one force. This one also one other force. This one we have another force, isn't it? This one is another force. One row, two row, three row. Supposing I'm focusing on row number 1 and row number 2, or perhaps row number A and row number B. Okay, so I have M equal to F, correct, multiplied by A, B. Correct. Let's say your M equal to 100 Newton. Let's also say that your AB equal to 1 meter. So you will have FAB is equal to M divided by AB. AB is equal to 100 divided 1. You will have here 100 Newton. Am I correct? So now you also know that toward the end of the bar, or perhaps plate, you have another one, another ball and nut. So this one be pointing. This one's not correct. Sorry, yeah. This one is supposed to be pointing downward. This one is supposed to be pointing downward. This one is supposed to be pointing downward, pointing downward. Same thing as this one, pointing downward, also pointing downward. Let's see this one C. Okay, let's see this one C. So what you have? So if your eye is here, for example, so you'll be looking at one plate, another plate. This is your bolt and nut, bolt and nut, bolt and nut, bolt and nut. Correct not? This one is A, this one is B, this one is C. So the forces acting on that plate, is one force acting this one. This one already calculated. You have another one where you found that this is your M prime. Okay, so now this one from that we see this on front view, from front view. So I'm going to calculate FC now. Your F A to C is equal to M divided by AC is equal to 100. AC is, let's say, This one is 1 meter, this one is 1 meter, this one be 2, we have 50 Newton. So this is F A, this one is F B, this one is F C. So now, so in calculating the force, in calculating the force in bolt and nut, bolt, B-O-L-T, bolt and nut. So I'm asking you now, which force should be considered? You tell me now. You have one A, FAC is 50 Newton, another FAB is 100 Newton. So which force are you going to look for?
C.
FA?
C.
Is it the one? Is it the one you refer to?
Yes.
Okay. Why?
Because
As engineer, you must have reason. Why you select this one?
because it has the lowest
Force, the shorter distance or the longer distance. In flexural, F-L-E, T-U, flexural. Flexural is displacement. Sorry, it's not displacement. Flexural is deformation. It's deformation. Deformation. Or deflection. You get me? You have a long ruler, which is the tendency to fail to give a more flexural. The shorter ruler or the long ruler. Doesn't bother about the forces now. Which one? The long ruler is much easier to fill because flexural. Flexural means it is easy to deform. It is easy to deflect compared to a short ruler. So even if you have a so big force, yeah, but when the distance is so small, it's very difficult to fail. When you have a comparing to have a small force but a longer distance. So in conclusion, even though you have so many rules here, for example, yeah, you have a plate, you have 1, 2, 3, 4, 5, 6, for example, bolt and nut. Don't bother. Okay, as long as this one your M prime, you take this one, the longest one, take the longest distance. So the longest distance or length. The reason is why? The reason is because it's flexural. It's easy to deflect. Easy to deflect. That is one. The other one, when you view from top, you found that this one, yeah. Let's see, we're talking about just now. You have only 2 rows, isn't it? This one, 2 rows. Okay. Oops, sorry, I'm constructing different one. Look at this one. How many rows you have? Only 2. 1 row and 1 at the front and 1 at the rear. So you have this one at this one, here. Okay, you already calculated this one. Sum, this one sum. So you have that F is equal to 100 divided by 2 equal to 50 Newton. But remember, this one is occurring only the front, this one, only this one. You have another one. So you need to divide it by 2 because why? Divided by what? Divided by
number of bolt.
Number of rows. It's not number of bolt, number of row. How many rows you have? 2
3.
rows. 2 rows, yeah? This one is not counted. Only this one. Okay. So if you have 6 rows, so divided by 6. So it's this one. Let's say you have another one and have another one. Then 1, 2, 3, 4, 5 divided by 5. Yes or no? Correct or not?
No.
Correct or not? No, it's only divided by row. It's not divided by number of bolt and nut. Divided by number of row. Because what you being calculated the front one. Look at here. You being calculated is the front one. The front one is this one. The rear one, you still have another one, isn't it? Correct? And it's occurring in the same plate. So you have to divide it by number of row. So there is one in your conclusion here. I divided this one by 2 because number of row. Take further. This one is number of the row middle. This one is number of rows. Okay. Is that clear?
Yes, Doctor. Doctor, so nanti yang the other books tu kita just neglect lah dia punya force dulu. Tak payah kira lah.
Are you talking about this one?
I mean kalau ada banyak lah macam ada A, B,
Yeah,
C,
you
D.
don't have to take the longer distance from bolt to bolt.
Oh,
Okay, take the longest one. Then how many row you have? You have 6 row divided by 6. If you have only 1 row, you don't have to divide anything. You divide by 1. This one very fortunate. We have 2 row. 1 row here front. The other one at rear. So divided by.
alright.
Okay, this one. If this one, let's say if you take this one you have another one. Let's see, yeah. Now let's see now. If you really understand, I put a different number blue. So let's consider for this one. So you view from this one, and you have a force here, for example. So that will be 1 force here. This one will be force here. So you divide it by what? Calculation, same calculation, but you divide it by 3. Yes, thank you, Walid. Yeah, because you have 1 row, 2 row, 3 row. Remember, this one not 2 but become 3. So divided by number of row. Just remember that. Okay. Okay, that's the one. I think you have this one with note in your notes. This one I already gave you. Before we move to this one, I would like to share with you one of the example in your problem, yeah, on page 100, 200. If I have ample of time, I will try to solve this one and also this one. This one is the reason I pick up this one is because this one is related with the topic that we discussed today. So I'm going to solve this one with you. So you have, if you have the, you can. Okay. You have with you in a new screen in your class. Okay, the electric motor has a mass, thank you, Lynn, has a mass of total 10 kg, supported by bearing A and B, bearing A and B, bearing A and B here. And again, I did mention about the bearing basically, the bracket is basically housing, the bearing housing. Sorry, you have the ball bearing, then housing, bearing housing. The bearing housing is typically held by the bracket, so that is the housing for the whole bearing. So A and B attached to the rotating disc. This one is the rotating disc. The armature of the motor given here 2.5 kg. This one, the radius of gyration given 35. You don't have to copy this one. You have this one in your notes and also in your books. Yeah, and the turntable. This one is the turntable revolves about its vertical axis at a constant rate of 50 rpm. So determine the vertical component. Look at the vertical component. You don't have to look for the resultant because you're talking about vertical component of the forces supported by the mounting bracket A and B. So this is the mounting bracket A and B. So as usual, as I mentioned earlier, so you have a procedure now, yeah? So the procedure number 1 is by write down the equation. Then start calculating on each term. I, for example, this one they provide you one. They provide you the radius of gyration. So you have the equation mk square. So the m will be, the m is not 10 kg because this 10 kg is total mass. You know what total mass is? Electric motor have total mass, meaning that the casing, when you open up the casing, you disassemble the casing, you will have the armature. The armature will be the winding of cable or wire, yeah, on the shaft. So on the component weight 10 kg. So that is the that one is not rotating. The one is rotating is only the armature. Armature rotating 2.5. So put it at 2.5 divided multiplied by K is 0.35. So you have the results here in kilogram meter square. I have a numbers here that provide is 0.0031. Okay, one term equal omega is equal to what does omega now? They provide the omega as look at here. These I know the armature running with the speed of 1005. So put it at n by 1005 divided by 60. You will have here. I also have a numbers here 157.1 radian per second. Number 3, the precession. The precession is only 50 rpm. Constant rate. What does it mean by constant rate, class? What does it mean by constant rate?
Acceleration 0.
Sorry,
Acceleration 0.
what does it mean? Anyone? Yes, Khalid. Yeah, Walid. Yeah, thank you, Khalid. Walid. It's basically there's no changes in velocity, and the velocity do not change, meaning that one the acceleration doesn't matter. The acceleration tangential or the acceleration on normal is becoming 0. So you have this one, and you have the omega. Sorry, the precession will be 2 pi by 50 divided by 60. Then you, if you calculate this one, that give you 5.24 radian per second. So you have all together numbers here, the magnitude, you put in the equation. So that will give you m equal to, if my calculation is correct, you have 2.6 Newton meter. This one is the couple. Okay. Okay, number 2. What you have to number 2 is to construct gyroscopic vector diagram. To construct the gyroscopic vector diagram. It is not very difficult. Again, how to construct is by applying the thumb rule, applying the right hand Fleming rule. Then you look for m. So how do you start? Thumb rule always start with spin velocity. Then you have the precession. This one will tell you about m. M is coupled. So now we will try to do whatever you have understand here. So if I can start with here, this one is the spinning, so you have to view from one end, for example. Yeah, she's saying that I'm going to view from this one. Yeah, this one viewed from here, and the other one is viewed from here, from A, because the equation asks us to do so. So if you are looking at point A, so this one is rotating what? It's rotating what? Clockwise. Am I correct or not? Correct or not? So you will have here omega. Okay. Then you look from top. You found that it be rotating. Again, it's also rotating clockwise. You found that this one is your precession. Then if you construct 3D, for example, you will have this one, the spinning velocity. This one is the precession velocity. Then you use your right hand Fleming rule. So you have the what? You have precession here, then it's moment here. Isn't it? So where will be the moment? Class, where will be the moment? Where will be the moment? Moment
The
because
set direction.
yeah, couple. Yeah. Sometimes I call it moment, but basically it's couple. This one pointing downward, isn't it? This one, that one. So the moment will be pointing that way. Very difficult when I show you in video, because you will be absorbing, or you'll be observing my reflection. It's not the actual things. If you can meet again, inshallah, we can now start doing the actual things. So this one is the M active. This is not our concern because we are talking about bearing. So or bracket. This is our concern, the M reactive. But even though you have to put the active, for the active, it is pointing to me, isn't it? Rotating what? That way. So it is rotating that way. So rotating counterclockwise. This one pointing inward the screen. be rotating clockwise. Rotating clockwise. So this is now all on effect. Put it here for effects. But of course, in test, the exam not do this one, yeah. After all, the lecture will be, finding or perhaps look so your work will be so messy, yeah. So this is your note, your personal notes only. So if you want to construct 2D, for example, some of you might be happy to construct 2D. So what you have here, you will have this one, omega. You will have this one pointing downward, precession, and this one will be omega, precession will be pointing to you. So pointing to you will be a point, isn't it? Yes or no? So this one be your M active. It's pointing to you, so be rotating that way. Pointing to you, be rotating that way. Same thing, isn't it? Clockwise. Counterclockwise, sorry, counterclockwise. And for the reaction, we have same thing here. Excuse me, omega. This one is the precession. This one will be inward your screen. So as inward in screen, so you will have a cross one. And this one will be that way. M reactive. And it is rotating clockwise. So you can choose to construct this one, or you can also choose to construct 3D is up to you, where you feel convenient to you. Okay, then we do analysis. Remember, analysis. Analysis is basically the effects. Analysis is basically the effects. Okay, analysis is basically the effect. So now, let's see. I'm going to use analysis on dynamic first. Dynamic is due to gyroscopic vector diagram as we discussed earlier. This one will be on statics. Of course, in static is constructing free body diagram, then applying equation of M equal to 0 summation, yeah, and also summation of F equal to 0. Okay, so I'm going to do dynamic analysis. Dynamic analysis. How is it? It's not very difficult. This is my motor. This one is my bearing. This one again my bearing. Of course, the bearing will be in the inside the brackets. Yeah. So this one, let's say this one A, this one B as provided, and I will pick up the we know that this one is coming from the gyroscopic vector diagram. You pick up the reactive just now. Reactive is this one. If I can change the color here, so this is the reactive. Pick up this one, or you can also pick up this one if you do the 3D. Now it's be rotating clockwise. So put it here. It will be rotating clockwise. M reactive. Correct or not? So your M is equal to what do you have just now, M? M is equal to what do you have as M just now? 2.6. So M equal to 2.6 is equal to 2.6. But M is also F multiplied by this one, 250, isn't it? The distance between A and B, 250, put it here. 250 is 0.25. So therefore, your F equal to 2.6 divided by 0.25. If I can take my calculator, where is my calculator? Yeah, I can take my calculator and calculate that one. You have 2.6 divided by 0.25, that provide you 10.4. Am I correct or not? 10.4 Newton. And this is ANB, isn't it? So you have 10.4. Complying the clockwise direction, you have F here. FA is equal to 10.4. You have another one, FB, also 10.4, but it be pointing downward to comply the couples. Is that clear? Yes or no? Hello?
Yes, doctor.
Yes, doctor.
Of course, yeah, this one also, we are assuming it will fall at the middle because they put it in. Look at it, put CG at the middle. Okay, they put at the middle, so it will be at 250 divided by 2 is 125. Okay, so that is on a dynamic. Then you do static analysis. Static analysis. Static analysis, you have to construct free body diagram. It's not very difficult. Constructing free body diagram. So you have this one, ZAP. This one is mg is equal to 10, because when you're constructing the free body diagram from static, look at the whole entire mass. The reason is why, because the bearing on static is due to weight, which is mg, which is 10 by 9.81. 2.5 just now is a part of the motor. So now you have another one. Let's see, this one is bracket A and B. This one pointing upward for RB, pointing outward for RA, and assuming this one is at the middle, as I mentioned earlier, you have this one is 125, this one is 125. Okay, then as usual, you do the calculation, calculation of the what do you call it, moment. Yeah, you have this one, then saying that rotating that way as positive, you are calculating here as RB, RB equal to 0. You have, okay, RB multiplied by 0.25, isn't it? Then you have what? You have, okay, minus by mg, correct? Put it in numbers, easy for us to calculate. Yeah, we have 10 by 9.81 multiplied by 0.125. That will give you a B. Okay, so what do you have there? Divided this one and this one is 2, 5. You have 4905 Newton. Am I correct now? Thank you. Yeah. The other part, the other equation is so we use this one. Yeah. The equation first before we do the number equal to MA equal to 0, saying that anything that pointing outward equal to 0 equal to positive. So what you have this RA plus RB equal to mg. So you will have the A is equal to 9.81. This one RB is minus by 4905. You will have the same results. And this one also positive is pointing upward. This one also pointing upwards. Whatever you constructed, whatever you want, whatever you assume is correct. Yeah. So now, but remember, we are dealing with bearings. Yeah, it is not dealing with shaft. Yeah, so it will be pointing downward for bearing, pointing downward for bearing. This one is shaft. This one is bearing. This one is shaft. This one is bearing. Okay. So then you put all forces on the mechanism. Is it compulsory? Yes. Do you get mark? Yes. So what you have here is so what you have just now, you have earlier was 1005 at 1004. So this one is A and B. A and B. FA equal to 1004 Newton. This one you have FB equal to 1004 Newton. Then what I have, what you have for the bearing, both are pointing downward. So you have RA here. A is equal to 4905. This one you have also pointing downward. RB equal to 905 Newton. So these are the result now. Okay, these are the result. The component of forces acting on bearing is acting on bearing due to gyroscopic and also due to weights. But supposingly, I'm saying that if the question keep asking you about resultant, for example, okay, resultant, for example, yeah, this is the extra or advanced equation. This one is the advanced equation. Okay, resultant, for example, so we'll have summation of F, for example, for bearing what? Let's say for bearing A. This one is resultant equal to FA plus RA. If we're saying that this one pointing outward, for example, so you'll be getting here, inshallah, 1004 minus by 49.05. You'll be getting a results of here in Newton. So what you have there, you will be getting here as, what do you have here? 10 by time 10 minus by this one, what do you have? We'll have 38.85, 38.85 Newton. This one, yeah, this one don't read. This one, yeah, let me, this one, yeah.
Kenapa resultant cuma ada FA dengan RB yang
Sorry? Oh, this one is supposed to be RA also. Thank you. Yeah, this one's supposed to be RA. If we're talking A, all A's, yeah. This one very fortunate because A and B is equal, isn't it? So we have A such manner. If you are saying that this one negative, yeah, negative. If you are saying that for B, for example, we have summation of FR is equal to FB, this one plus RB, for example. So you'll be getting here is FB is 10.4 plus RB is 4905. If I punch in this value in my calculator, that will give you 59.24 Newton, pointing downward. This one also pointing downward. If you're saying the pointing downward, so you have to get rid the, when you are saying that is equal to 38.85 Newton, pointing downward, so negative is vanished. It's no longer negative there.
But can I see the step above? I want to
Sorry?
see the static one.
So don't bother this one. Sometimes you can also see this one is pointing down. Doesn't matter. Doesn't matter, yeah. As long as both will be pointing downward. This one is not so restrict, not so restrict. TRICK restrict. So this one is what you assume. You assume. You assume. Or your assumption, It's not always pointing upward. It depends. Sometimes you can also put the one, but of course, yeah, when you put one pointing upward, both are pointing upward. This is what we call as boundary. What? BC is what boundary? Boundary one? What is that called? Boundary? Boundary condition. So effect, another effect, remember? Another effect is what? Effect on body. We have two effects just now, right? What is the two effects? Can anyone name it? The two effects. One is on body, the other one is on. The other one is on. Anyone? The other one is on. You don't want to answer? I will leave it like that. Okay. So you
Bearing
the other one is on.
on point on.
No, that is one. I already discussed this one in first meeting. The other one is on. Would anyone? One is body. This one. The other one is on. What we done earlier. This one on one. Not on bearing. The other one is on. Anyone? If you don't answer this one, I just leave it like that. So you have to think about it. No, okay, no one dare to answer. So you think about it, yeah. So effect on body now. That system, no, not in system. What we calculating this one on what? We are calculating this one on what? This one on all this one on what? This one or all on what? On what? Mechanism, not mechanism, Walid. Yes, structure. Thank you, Eva. It's a structure due to the structure. What we calculated earlier was on the structure. So this is based on the structure. So there is two effects. One is on the effect on structure. The other one is effect on this body. So the effect in the body, you have to look the effect of the this one. Look at here. So the effect on the body. Yeah. If I can share you back here, effect on body. So you have to figure out this one, effect on body. Then you have to look at this value. So you found that this one is pointing downward. This one is also pointing downward. But this one is only 38. This one now is 59. So what does this mean now? What does this mean? It simply means that for D, B will be pushed down. What? B will be pushing down. What? B will be pushing down more, right, compared to A. B will be pushing down about 52.24 Newton, whereas A only 38. So B will be pushing down more compared to A. So that is one. The other one, if you're talking about, for example, so let's say we are talking about CTPS. So let's say now, which bearing will fail first now, bearing A or bearing B? So which bearing will fail first now, bearing A or bearing B? Anyone? You have 58 and also 59. Which bearing? Bearing A or bearing B? Bearing B, yes, bearing B, correct, yeah? Okay, correct, bearing B is correct. Bearing B has tendency to fail first because the limitation of the bearing B is only up to 38.85 Newton. Reaches 40, it will start giving problem, whereas the B now is still running steadily until it reaches or exceed 59. In designing purposes, you have to look for this one, the highest, but of course, to these numbers, you need to multiply by safety factor, as we know that safety factor is the key of safety, to ensure that the structure that you design will not fail or running running in proper manners. Yeah. Okay, that's about it in example 13. So I'm going to move on to another one. Any question before we proceed, class? Any question? No? Okay, I'm going to move to the next one. This one you can do this one on your own. This one is not very difficult. If I have ample of time, I will solve this one. Maybe when we completed the whole thing, I'm going to solve this one. This one also not very difficult. This one coming from couple of semester in the test, as also this one. Yeah, this one is in the exam, I presume. Let's now move on. This one, aeroplane. Airplanes, yeah, or aircraft. So doesn't matter whether the airplane run by the propeller, one propeller, two propeller, doesn't matter, or it can be if I run by the rotor, it doesn't matter as long as the rotor will be rotating, the propeller also rotating. Yeah. Okay, now. So what our concern now is the equation we use is exactly the same. Your equation is the m equal to I dot omega cross or spin cross position is exactly the same as what we did earlier. The only difference now is the motion. Okay, likewise the aeroplane. The aeroplane can what? Turn to left toward me, yeah, turn to left pointing up. The position will be pointing upward. Turn to right, the position will be pointing downward. Remember? And perhaps the aeroplane what? Roll a bit clockwise, be pointing to you, pointing to the screen or inward the screen. Roll a bit counterclockwise, be pointing to me. So that is the motion, yeah. And beyond that, the aeroplane can also what? Can also this one, yeah, can also climb. This one climb. So it be pointing to you or to screen. Diving, for example, for the sake when you have airplane tendency to take off and also landed, this one is our landing. This one will be turn. This one will be diving. It's not diving. Diving in the meaning of the diving. Yeah, basically the nose or the front end of the airplane be pointing downward. What you call the descending. This one, yeah, be point. This one be pointing downward. Be pointing to me. The precision. So the precision will be turned to left, turn to right, roll clockwise, roll clockwise, diving and climbing. So the spin is always due to the rotor, whether the rotor will be rotating clockwise or counterclockwise, view from front end or tail end. Okay, so when you are talking about aeroplane, yeah, if you remember in your study, okay, yeah, let's say this is the aeroplane. I'm not good in drawing. The aeroplane take a left turn. This one is left turn. Okay, there must be a what? There must be a this one will be must be center of rotation. And assuming this one is rho, Assuming that what is rho? Is rho is the radius of, rho is equal to radius of what? Radius of what? Of
Curvature.
radius of radius of radius of radius of what? Yes, radius of what?
Curvature.
Curvature, huh? Radius curvature. So this is a radius curvature. So supposingly at that particular instant, the velocity will be this one, the velocity. They provide you the velocity. So you know that this rho, you have to look for the omega. Okay, the omega is equal to or perhaps I can start with V first. Oh, stop now. Perhaps I don't want to start with this one. Confusing. I start with the V now. The velocity. The velocity is equal to the omega cross. So I'm not going to use this one. I'm going to use the principle that you study in dynamic. Omega cross R. But there is no R here. R now is equal to rho. So you put here equal to omega cross rho. But you're confusing with this omega of the engine, isn't it? So you're confusing this one. So you change this one to become precession. So you will have the velocity is equal to the precession multiplied by the radius. Oh, sorry, multiplied by the rho. So the precession now is astaghfirullah. The precession now will be the velocity at that particular instant divided by the rho. In my notes, I put it here, the velocity divided by the capital R, where the capital R is basically radius of curvature. So do you have this one? Or if you can turn to page your books, yeah, you have this one. The other parameter is exactly the same. There's no changes in other parameter except for this precession. When the aeroplane climb, of course, it will be climbing with certain velocity. It will not running with the same velocity as turn to left and turn to right. So you need to another velocity, and you also need to another radius of curvature. So at any particular instant of the motion, so they provide you the speed, the velocity, and also the radius of curvature. Bear in mind on that, yeah. But if you're very lucky, for example, they will provide you only one speed and only one radius of curvature toward all the motion. That one is much easier. Okay, let me go to the next one. This one, as I mentioned earlier, on the motion. On the motion, yeah, turn to left and right, so on and so forth. And this one is, how to construct the gyroscopic vector diagram. So as I mentioned earlier, for this number one, calculating m equal to I dot omega cross, this one is not a big deal. I is typically the mk square, or it can also written as half m r squared depending on the parameter given. The omega is the spin velocity due to the engine is 2 pi n divided by 60. And the other one, the precession, is due to the velocity at that particular instant divided by r, where r is the radius curvature. So this one is no big deal. It's no big deal. Okay, number two now, we are going to look for gyroscopic vector diagram. So you go back to the notes, we're going to look for gyroscopic vector diagram. Look at this one very careful. So let the rotor of the engine is rotating in clockwise direction, looking from tail end of the aeroplane. Supposingly this one is the aeroplane. Okay, this one. You know this one, this you have four figure. You take the bottom left. The bottom left is your aeroplane with the motion. Then you find that if you are wing from one end, for example, you know that it be rotating what? It be rotating clockwise. Or if I can put a rotor, for example, so the rotor typically given this one as this one. This one is the rotor. Then you are here. So the rotor will be rotating one. This one from one end, this one is rear end, this one is the front end. So if the rotor is rotating clockwise from the rear end or front end, depending on where will be the information provided in the test or in the exam. Yeah. So now clockwise, looking from the tail end. So looking from tail end is clockwise. So now if you are here looking for the tail end, this one tail end, rear or tail end, yeah, rear or tail end, clockwise. So you put your hand this one, you put this one on the engine clockwise, looking from this one, clockwise. So it will be pointing that way. Am I correct or not? Omega. So you go back to here, you will have this one. Okay. Then what happened to the aeroplane? Right turn. So right turn, right turn. So right turn, if this is the aeroplane, this one pointing upward is toward my left turn. Pointing downward be right turn. Am I correct or not? So now it's pointing downward because the airplane back a right turn. So pointing downward. As it's pointing downward, as it's pointing with right turn, so the precession will be pointing downward. So you have to this one, you put in the Jasper vector diagram. Spin velocity, precession velocity. Then you put your finger, applying the right hand flaming rule. This is the spin, put it on spin. This one will be your precession, put in the precession. So this one will be your couple. Couple will be pointing inward of your screen. So this one is couple. Active. Remember, active. And this is not our concern. Effect is always reactive. The calculation for the force, if supposingly the just now this one, yeah, the rotor is with so many rivet here, but you have to look for the furthest one. So the M equal to F multiplied by this one is point A and point B, multiplied by point A and point B. Okay, then you look for M calculated earlier, what is B. So this one structure is as usual. So the structure calculation is as usual as what we did for the rotor and shaft. This one is on body. This one effect on body. Effect on body. How is it? Look at here, the reactive. Put it the reactive. This one is not correct. Yeah, this one. Sorry, this one is correct. This one, yeah, reactive. This one is M reactive. So as it pointing downward, so whatever now, so the nose will be this one. You have F. This one will be also you have F. So the nose will be pointing downward. The nose, dip the nose pointing downward, and the tail will be pointing outward. Is a raise the tail. So this is the effect on body. This one is the effect on body. So what does this mean? Yeah, what does it mean? Yeah, I got the aeroplane, but aeroplane is not with me now. I mean the replica is not the actual aeroplane. So supposing this one is the aeroplane. This is not aeroplane. Yeah, this is my calculator. Yeah? Supposing this one aeroplane. So while turn to left, look at it. While turn to left, what happened to the aeroplane basically? So the front end will be pointing downward, right? The tail end will be pointing upward. So it will be turn to right, but not turn to right at the same level, but turn to right where your front nose will be pointing downward, but where your tail end will be pointing upward. So it will be what? It will be basically pointing downward. Probably the airplane want to land it, for example. Yes or no? So it will be descending because the front end is pointing downward. What will be the force on the body? We do not know because we do not know what be the dimension of the airplane, except they provide you. Sorry, unless they provide you the length of the airplane, then you know how much force on the tail end and also nose end. Okay. Now turn to left. Turn to left is exactly as for the turn to right, but except what? Except it will be opposite direction. For example, yeah, look at there. This one not change because you are still flying with the same engine. This now new one change. Instead of pointing downward because right turn, this one pointing outward due to left turn. So pointing downward, this is your spin. So your next finger or your middle finger pointing to you. This one is pointing to you, active. And this is not our concern. It's pointing the other way. It will be the M reactive. If you put in the 3D, this one is 2D, this one is 3D. You have the spin velocity, you have pointing upward because it turned to left. Then you will have what? You will have active, and the active will be that way. So this one will be on structure, and also this one on structure, and also on body. On structure we already calculated earlier. So if you put this one in aeroplane, for example, you take this one, put it in aeroplane, and will be that direction. What does it mean now? To comply this reactive, you must have one force acting upward. You must have one force acting downwards, isn't it? So what does this mean? So it simply means that it will raise the nose. If you forget what nose, you just put front end and rear end. It's okay, yeah. And it's dip the tail, dip the tail. So what does this mean exactly in the actual phenomena? Yeah. So if the airplane now turn to left, for example, it is not turned to left by the same plane. No, it turned to left, but it also climbing, isn't it? It turned to left, but also climbing, because the front end now is raised, and the tail end will be dip a bit. So it will like climbing. Perhaps in other manner, yeah, it will be while takeoff. After takeoff and now reaching at in the air, so it will be turn to left, for example. For example, that's just for example. Of course, when you fly with Airbus 310, for example, you don't feel anything except when you feel a light aircraft, then you feel something when turn to left and to right and descending and also ascending. Okay, that is one. The other one will be rolling. It's also not big deal. Yeah, so rolling as usual. It can roll clockwise. It can also roll counterclockwise. So when roll clockwise, be pointing that way. Roll counterclockwise, be pointing the other way. So the only beauty things about the rolling is, look at here. We still have to use the same engine here. This one. Assuming that you are rolling what? Clockwise, viewed from tail end, clockwise. So you'll be having the same parameter as the omega and also precession and spin, isn't it? We will have the same thing. So if you construct for example, yeah, if you construct the polygon, for example, you will have what? You will have this manner, correct? You will have this one, where the spin and also the precession will be at the same direction. So what will be your moment? Your moment equal to what just now? I dot omega cross precession. This time around, omega is not crossed with precession. So m equal to 0. Remember equation that you use in Cartesian coordinates? I cross I equal to 0. If for example, x, y, z. I, this one is j, this one is me. I, you have I cos j, this one is equal to I cos j is equal to anyone? Am I talking alone here? Yes, thank you, Lynn. I cos j equal to k. If you found that j cross k is equal to j cross k is this plane equal to I. If you found that this plane, yeah, I cross k equal to I cross k, this one equal to j. So what if you have I cross I equal to 0? So what you have omega cross precession is equal to what?
0.
No, you have a unit here, isn't it? But what if you have omega? Oh, sorry, I'm sorry. What if you have I cross I equal to 0? What if you have I is not cross? This one, yeah, cross, yeah. So what if you have I cross I is correct, but when you have the I sorry, astaghfirullah. What if you have omega dot omega, or you have omega dot this one? What do you have here? I cross I is 0. So is omega cross this one equal to? Forget about this one. Dot. Look at here. If omega cross omega, if this one is omega, this one also precession. So this one equal to? Equal to what? Equal to what? Equal to? No, equal to m. Look at it. If this one is omega, equal to 0. Yeah, thank you, Eva. What if you have I cross negative I equal to what? You have I cross negative I equal to what?
0.
0. So what does it mean now? You have omega cross negative precession. So the precession will be here. Equal to? Equal to? Equal to? Also 0. I remember that. Huh? This one is also 0. So we come back to this one. There is why this one there is no moment as one, as this one is not cross. This one is fall on the same plane. So becomes 0. Even though from the very beginning when you calculated on numbers, you have a numbers, but basically it becomes 0. So that is why in practical, yeah, you found that even though the aeroplane keep rolling and rolling and rolling, for example, yeah, with certain speed, for example, it will not fail. It will not, fall or whatever it is, because due to there's no couple effect on the structure. The structure will not fail. Huh? Okay, this one. So this one you have omega cross here, isn't it? This one, sorry, omega, same direction. This one also but negative. This one both positive, this one positive, this one negative. One is I cos I equal to 0. The other one is I cos negative I equal to 0. Okay, that is one. The other one, climbing. This is more challenging. Climbing, yeah. Climbing simply mean that you can climb this one ascending. Sorry, ascending meaning that when the front end will be ascending, it pointing upward. When diving is the descending, the front end will be descending, will be pointing downward. So when ascending will be pointing to the screen, when descending will be pointing to me now. You can do on your own, on your perception. Because different perception, different view, you point that it will give you different answer. I mean different answer of the rotation, but at toward the end, you'll be getting the same results. Okay, now let's say that we have the same engine, and then this one is what? When you are climbing, this one, put it there, climbing. Climbing is the, the precision pointing inward. So you will have this one, right? So you have spin, you have precision, the next one will be couple. Couple will be pointing upward. Couple will be pointing upward. This one is couple pointing upward, and it is not the reactive. So you do the reactive. This one is not correct. Yeah, this one is correct, but this one is not correct. It's supposed to be dots. Look at your notes. Correct notes. I mean, look at your books. Correct notes. Take out your book and look at your books. Your note is not correct. It's supposed to be not point. I think your book is correct. Yeah, I already do a correction in your books. Yeah. Climbing. Yes. Yeah. Your book is so not correct. Yeah, look at your book, class. Oh, sorry, it's correct. I'm sorry. It is correct. It is correct. Yeah, it is correct because it pointing downward, one pointing upward, the other one pointing down. It's correct. Correct. Both correct. Your book correct. Also, your note is correct. So this time I want to look at here. When this is pointing downward, so if you put this one on aeroplane, for example, take this one, put it in aeroplane. What happened to the aeroplane now? This one is F. This one also F. So to comply this direction, so this one F, and it will push toward, this one is toward right, this one toward left. So the aeroplane is pushed toward right. So now explain to me, what do you have on structure now? So what type of force on structure? Could anyone tell me? What do you have force on structure now? If you found that this one be pointing downward, and this one, the force now occurring on the surface. Remember I mentioned just now when the force occur in the space, you will have the what type of force? What type of force? Anyone? Anyone? I got 55 participants, all engineers to be inshallah. not couple. It is couple. I mean type of force. Couple is not type of force. Remember type of force? Shear force. Thank you, Chin. It says shear force. When you have a force on the surface, yeah, force on surface here, for example, this is, you know, this one on surface. The force will be on surface, so it will be shear force. But if you have a force now, it is not perpendicular to the surface. This one is perpendicular to the surface. It become compression or tension. Just remember that, yeah. When on surface, it will be shear force. When perpendicular to the surface, becoming tension or compression. Okay, so climbing is opposite the driving, yeah. So diving now, so the diving will be, the front end will be descending. Just now ascending, this one descending, pointing downward. So same thing here. This one is omega. This one now is diving. So diving now will be diving. So the thumb will be pointing to me. As pointing to me, you will have this one dot. Then you have what? This one, thumb pointing to me, you will have this one. This is the active. This is the active. And this is our concern. Our concern is to look at the reactive. So if you put this one on the structure, for example, so it's pointing upward. So the aeroplane will be what? The aeroplane will be pushed toward left. Push toward left. So what does it mean? Yeah. So it simply means that the airplane climbing or diving not at the same level. It be climbing, but at the same time it push toward left or push toward right. When climbing, you will push toward right. When diving, you will push toward left. Do not memorize this one. This one is depending on what? On the engine, on the propeller. When you view from one end, if you view from front end, for example, then it will be rotating clockwise. You will have the same. You will have different results. So do not memorize this one. You have to understand everything that we discuss here. No point of memorizing whole things, yeah. Okay, again, when the force now acting on the surface, it becoming what? It becoming a shear force again, yeah. So that the completion of the theory for the airplane. This one, yeah, this one a part of explanation talking about what happened when this one, yeah, this one climbing, and you see that climbing, but then you know, it's this one, yeah, climbing, but now it be turn to left. This one, look at here, and look at the other one. I did mention about, before I forget, yeah, I did mention about helicopter. How to spell helicopter? HELI. Easy to pronounce, but different in spelling, yeah. Helicopter. Helicopter. Isn't it? So I'm not good in drawing, so don't laugh when I draw something. Let's see, this is the helicopter. Does it look like a helicopter, class? Look like a helicopter, no? This one is the leg. This one you have propeller, remember? You have another propeller, big propeller, we call main propeller, big one. This one is, we call it maneuvering propeller. This one we call the main propeller. Sometimes we call it a primary propeller. This one is a secondary propeller. Okay. Secondary propeller. Why cannot? This one is secondary. Right? Secondary propeller. Okay, look at here. Very, very careful. If you're talking about a helicopter, you have to do one roto. This one we call roto, yeah. Roto, one roto after another, meaning that after another, meaning that number one, for main or primary roto, you do everything as what we did earlier. Then number two, then for secondary roto, for example, do something. So do not mix together. Okay, do not mix, because this is, you cannot plus the force for this one to that one. No, Okay, you do have to do one after another. Okay, you have to do one after another. Okay, I think we still have a couple of minutes before we end our session today. So I'm going to move to the example. This one, yeah. This one you have this one. You have the rotor. This one is the main rotor. This one ED. What you call maneuvering rotor. This one is Novi. So also same thing. So you have to do one after another. For the main rotor, you have all the forces. Then for the main rotor, the maneuvering rotor, you have all the forces. Okay. We are going to look for example. Yeah, turn to page 172. I'm not going to this one. I'm not going to do this one completely or in detail. I'm going to explain how basically to go about it. Let me go to your notes. Oh, I'm explaining by your notes. Okay, example number 4 on page 100 and 171. Take out your notes. So a rotary engine and propeller of aircraft with 300 kg have a radius of gyration. This one, yeah. So you have to use what? I equal to mk squared. The propeller shaft rotates 12,000 rpm clockwise, viewing from tail end. They mention this one. The magnitude, the direction, and the point of viewing. There must be three information. The magnitude, 12,000. The direction, rotation of is clockwise. The point of viewing is from the tail end. If this one is given, this one is not given, this one also not given, you have to do your own assumption. And the aircraft flying with a speed of 250 kilometer per hour. So the engine and propeller is fitted to the wing by number of bolts. So many bolts in one line, and the farthest distance is 0.5. Look at here. The farthest one is 0.5. A number of so many numbers, so 100, yeah, I don't know. But what they mention now, take the longest one is 0.5 meter. We do not bother about the intermediate bolt and nut. So determine the reaction. It is not resultant. Yeah, reaction mean what? We have to do the component forces due to static and also dynamic if they provide you parameter. And so on the bolt and nut, on the bolts, and the magnitude of adjusted couple, and also state its effect on in the following cases. So what are the cases? The aeroplane climbing, complete half, meaning that half circle with the radius of curvature 1000 rpm, or this one is 1000 meter. So then the aircraft take a left turn, radius this one 500 meter. Then finally the aircraft make a rolling motion at the angular velocity of 5 radian per second. They're mentioning about what? The aircraft make a rolling motion. They do not mention about clockwise or counterclockwise. So you have to do both. One is clockwise, the other one is counterclockwise. Except or unless they provide you aircraft make a rolling counterclockwise motion, then you have to pick up only once. Otherwise, you have to do both. Yeah. Okay. Now, so this is the CTPS equation. What are the equation? What is your suggestion? Suggestion in solving the effect of just couple, if the aircraft make a motion in equation 1 and 2 simultaneously. What does this mean? It simply means that while climbing, the aeroplane also make a left turn. What we did here is basically an aeroplane make a motion one after another, one at a time. After climbing, then take left. Take to left. It's not take to left. Yeah, take to left. Uh, it is not actually impractical. Impractical that while climbing, the aeroplane also turn to left or turn to right. While climbing, the aeroplane also make a roll, for example. So this is what occurring in the practical. So the question here asking you what is your suggestion when these two motion occurring simultaneously. Okay, so now as usual, we are going to look for one case after another. Case number 1. Case number 1, start with this one, remember? Then start calculating each term. You're calculating I correct, you're calculating spin correct, you're calculating precession, and you know well that precision coming from this equation, as I explained earlier. The v is the velocity at that particular instant while flying, which is at 250 km per hour. So you have these numbers. Then you multiply everything. You have 3,206 Newton meter. And if the question asking about the gyroscopic effect, so these are the numbers. The number is the same but opposite direction. Inshallah, you in my note, yeah. You are not. You going no. You are. You will. You will not. Inshallah. Eh? And as you move now for the second part, remember when you're calculating the magnitude, you also need to know what will be the magnitude stand for. Yeah. So stand for this one is to construct the vector diagram. What we call is gyroscopic vector diagram. We have a couple of minutes. Inshallah, we can complete this one. Okay. This one is view from tail end, as mentioned. It is, what does it mean? Tail end, and it is here. Look at here. Tail end, and clockwise, viewing from one end clockwise. So clockwise is this one. This one is clockwise. So if you are at the tail end of the airplane and at the rotor, for example, you are viewing the rotor, and the rotor, you can see the rotor is rotating clockwise. So we'll be pointing that way. Counterclockwise, be pointing that way. You can also put your plane here, but very difficult for me to explain. Okay, this one is very easy, yeah. So this one is clockwise, it will be pointing that way. So this one will be spinning. So now it turn back a left turn. This one be left turn. This one be right turn. Left turn will be pointing upward. Left turn will be pointing upward. So what do you have here? Sorry, number climbing. So climbing, yeah, climbing. Climbing. This one is climbing. This one is diving. Climbing when the nose is ascending. Diving when the nose is descending. So climbing, ascending. So you found that it'll be what? It'll be pointing to inward the screen. So it'll be climbing. So we'll have this one. Follow me in my hand here. Climbing will be pointing to you. So now we are spin, isn't it? Spin here. Look at your notes here. Spin. Then you have precession. Inward the spin. Then you have a couple. Okay, this couple pointing upward, and this is the active couple. You have this one, active couple. And this is not our concern. You inverse the direction, you'll be getting M reactive. The M reactive is the for X. Okay, effect, I mean all effect is effect on the body and also effect on structure. Remember that you have two effects on body and on structure. So the structure you have two, static and also dynamics. Yeah. So this one I provide you the 2D. This one is a 3D. Okay. Then as for the climbing, what you have is look at here. So this one is effect on body. This one is effect on structure. Okay, effect on body. Let's start with on structure first. Effect on structure, as usual. This one is not very difficult. You have M calculated earlier. You know what D is. Then you have F. The F is simply 6,413 newtons. Where will be the action? Look at here. The M reactive, collecting from this one, put it here. Then what? You will have pointing downward. This will be the direction. Remember, direction of vector, direction of rotation. So direction of rotation will be complying of this F prime and F prime. Isn't it? So you will have the same parameter. And we are assuming again, that this plate will be the uniform plate and it will fall at center. So this here. And the ball here is shear force, and name the force shear force. Okay, because it happened on the horizontal plane, on the surface. So for the effect on the body, look at the effect on the body. If the aeroplane, supposing this is the aeroplane, I'm not good in drawing of airplane. Yeah, this one the airplane. So you have here pointing downward, M reactive, and this one B1 pointing downward. You must have force push that way, and this point push that way. Isn't it? So it will push toward right while climbing. Push while climbing. How much force we do not know until or except when the equation provide you the length of the airplane, then you know how much force will be pushing the aeroplane toward left or toward right. Now this time I want to push it toward right. It's not very difficult, isn't it? Okay. Turn to left here again. When turn to left, this one as usual. This one not change, do not change. This one now is not change. This now is changing. Yeah, because why? You have now 500 R equal to 500 or your rho equal to 500 meter. It's no longer 1000 meter. You'll be getting a big compared to the other ones. Yeah, so you will have 6000 here. This one is very active. This one is reactive. Then you start constructing the gyroscopic vector diagram when left. Then how is it? It's not very difficult. This one is not change. Left turn pointing upward. So the precision will be pointing upward, isn't it? So this one will be pointing outward, the precision pointing upward. So you bring out your finger, spin, precision, the next one come couples. And the couple now is pointing to you. Couple so pointing to you, and this is the M active. And the M reactive is pointing the other way around, yeah, or the inverse or opposite direction of M active. You can put this one on your gyroscopic vector diagram. So this one is 2D, this one is again 3D, and our concern is reactive for the effects. So what are the effect? The effect will be as mentioned here. Effect on look at effect on bones first. Structure not very difficult. This one from the equation earlier, we have this one divided by 0.5, you have this one 12,000. It's so huge, it is so huge. And finally you have this one, you bring this one. Now look at here, it is what it'll be acting on the structure. It's not on the surface, yeah, or perhaps I may say that is a perpendicular to the structure or the plate. So to comply this one, you must have one force acting upward, one force acting downwards. What type of force? You have this one, tension or compression force. Oh yeah. So what happened to the body now? This is the for the body. What happened to the body? Look at here. You take the same thing. If this is the aeroplane, for example, this one. If I need space here. If a very quick one. This is the aeroplane. Zap. I take this one. The M reactive. M reactive will be here, isn't it? Zap. M reactive. So to comply this one force acting upward, one force acting downward. This one is F. This one is F. What does this mean? So the nose now is pointing upward. So the nose raise and the tail tip. If you forget about nose and tail, just put the front end also rear end. Okay, it's not very difficult, isn't it? Okay, now for the aircraft, I will explain to you. Hold with me a bit, yeah. I will explain to you why we don't take statics. Why static not considered? Not considered. Why? Later on, a bit. When you stay with me, I will tell you why static is not considered. Remember, for analysis, you have static and dynamic earlier, isn't it? So now I'm going to explain you later. So for the rolling, this one is M as usual. This one is I, not change. This one is the spin, also not change. This one now change. You put everything, you have the results. But when you plot the gyroscopic vector diagram, what you have is this one will be what? This one will be spinning, but now spinning. This one is clockwise, same direction. So you have omega here. It's supposed to be cross, but now omega is parallel, isn't it? Omega is parallel. So I cross I is equal to 0. Okay, so finally you will have as such. Look at you read the equation. So the therefore the magnitude of couple is 0. Sin of this one. Even if you calculated as such, it's so huge force here, but this not is not compliant because due to the vector. Okay. So I will explain this one a bit before we move to the statics. In solving Jacobic couples, yeah, when two motion occurring simultaneously, listen up very carefully here. You can calculate all the forces on structure. You can calculate all the structure, whether it is come from the compression, tension, or shear force. Yes, it is. You can calculate, but to define what happened to the structure, it is undefined. The reason is why, because these two forces are basically combined together. Sorry, these two motion is combined together. You cannot define where will be the structure effect. Body effect. So there is no body effect, or the body effect cannot be defined. The structure as usual, you can calculate the structure as usual, but you cannot tell what happened to the body, whether it is pointing upward, downward for the nose, and tail, so on and so forth. Okay, that's one. The other one is why static is not taken into account. Could anyone tell me why static is not taken into account? This one, why static not considered? If you don't answer this one, I just leave it like that, and you have to think about it on your own. We have 2 minutes before we dismiss. We'll end up 9:50. I'm trying my best to finish up exactly as the as the time provided, sir. So could anyone tell me why static is not counted here? Yes, anyone? I got with me because it's moving. No, it's not because moving, because we don't have bearing. It is bearing. You have both in that as mentioned. Why? Anyone? You can see and you can write as we write. I can read. Moving in vertical, no motion because we know vertical is no. 49 now. Up to 50, you don't answer. Up to 9:50, you don't answer. We don't know direction of rotation. We do know the direction of rotation. We do know that one. What else? Tan, Lin, Chai, who else? Nani. Anyone? Rolling element cancel out. The no, it's not rolling element cancel out. Okay, 1 more minute. 9:49 now. Anyone? Last answer. Doesn't matter your answer is not correct or not. As long as you can, because it's complicated. No, it's complicated. As long as you can respond in my class, so the class will look lively. Yeah. The reason is why. Look at here. The reason is why. Look at here. Yeah. The reason is why because look at the row 2 now. Can you tell me where will be the CG for the row 2? Remember, for static, you need to know where be the row 2 position, because you need to know what be the MG. So can you tell me where the CG for the row 2 now? Could anyone? Yes or no? Or can you define the MG for the row 2 now? Hello? No dimension, correct. There's no dimension, except they provide you what? They provide you here. Okay, this one is MG. Then you know that where will be the motor. For example, yeah. For example, 1 minute before we end, yeah. 1 minute. For example, if you go to do your tutorial later on, yeah. When you have 1 minute, I really need to see. Except this one. For example, this one. They provide. This is the row 2, yeah. This is the row 2. They provide you the CG. Then you need to calculate the static. They provide the CG. Then you need to calculate static. So as long as the CG provided in the parameter, you need to calculate the static. When you don't have a static, when you have this centroid or CG, you can ignore the static because you do not know where will be the parameter for the CG. Okay, so hopefully you understand what I'm trying to share with you. Yeah. So I'm sorry we have to hurry a bit to catch time. Yeah. So when I meet again, inshallah, I'm going to solve a couple of problems related with the topic, typically taken from the books. and also to meet, also to calculate or to discuss on the ship and also automotive. Then we complete everything. Then become your assignment. So toward today, until today, you can also start doing your assignment by looking at the assignment that you already learn in class. So if there is no question, I hope there is no question. I will add to. I would like to end my session. So is there any question? 20 seconds. Okay, no question. So thank you very much for being with me. Thank you for hopefully you enjoy my class. Patient with me. So with that, I end my session with Assalamualaikum warahmatullahi wabarakatuh. Stay happy, stay safe, and also stay healthy, and also stay study. Thank you, class.
Thank you, sir.